What is an encoder? Well, an encoder is a device that measures rotational position and velocity. What is a mag encoder? Well, a mag encoder does the same thing as a traditional encoder, only it uses a magnetic field to sense rotational position and velocity. The mag encoder, the CTR mag encoder that plugs directly into the Talon SRX, supports both absolute position and relative positioning. So what that means is you have both a quadrature output to tell you your relative position, and you have a pulse width output that tells you your absolute position within one magnet rotation. The mag encoder requires what's known as a diametrically polarized magnet. And what that simply means is the magnet, a traditional magnet, would be, let's say, north on this end and south on this end. That's what you call axial polarization. The magnet required for the mag encoder is polarized diametrically, meaning instead of having a north magnet or north pole here and a south pole here, you would have a north pole on this side and a south pole on this side. So your face of the magnet would have both north and south polarities. And this is essential for the mag encoder to work. You have to have both polarities in order for the device to sense its angle and position. Once in a while we'll get a question, do I have to use the magnet that's supplied with the mag encoder? And the answer is no, you don't. If you do choose to use a different magnet, you will have to find empirically what the magnetic gap can be, what the air gap can be between the magnet and the sensor itself. And we'll go over that here in a minute on how to tell what the proper air gap is. We do document recommended air gap for this magnet in the user manual for the mag encoder, but if you wanted to find it empirically, we definitely encourage that, and we're going to show you later on here how to do that. Quick overview of how the mag encoder works. Real simple, you just plug it into a Talon data port. You see this red LED illuminate, letting you know that it doesn't sense a magnet, or the magnet's too far away, or it's too close. So this LED indicator here is really all you need to determine your air gap. This represents the field strength of the magnetic field itself. So when you're red, you're either too far away or too close. When you're green, you're just right. And when you're yellow, you're either a little too far away or a little too close, but still functional. So yellow is acceptable and green is acceptable. Yellow, you have a slight, almost immeasurable difference in precision versus green. So you should strive for green. We like to say green is good, red is dead, but yellow is acceptable. So if you see an occasional yellow light in your application, that's okay. What you don't want to see is a red light. So I'm going to take this magnet here and I'm going to hold it up to this encoder, and you're going to see, hopefully you can see the LED still here in the video, but you're going to see the LED change. So here we're way too far away, right? And we move a little closer, a little closer, a little closer, we get yellow. Okay. We move back, we get red again. Okay, back to yellow. We move a little closer, a little closer, a little closer, we get green. All right, we move a little closer, a little closer, a little closer, we get yellow again. And if you move even closer still, you get red. So it's very important that you make sure the air gap on this is right. And you can see there's quite a bit of variance between green and yellow, and a big variance between green and red. You have a lot of play here. But every application is different, and when you're installing the magnet on whatever mechanism you're installing it on, you want to make sure that you get this air gap correct. Now, one of the nice things about a mag encoder is you can use it through any magnetically permeable material. So air, for example, water, for example, and even aluminum. This will pass through an aluminum plate, no problem. So one trick I learned when using a non-standard magnet, or the magnet that's not supplied, to figure out what air gap you should use is it's very simple. You're just basically going to shim between the magnet and the sensor, and you're going to measure that shim thickness. So here I have some paper shims that, just for illustration purposes, we'll hold up to the magnet, to the encoder, and then we'll impinge the magnet, impinge the shim between the magnet and the sensor. And as you can see, this will produce a yellow LED. Now, most likely it's yellow because it's too close. So if we pull it back a little bit, we see it turns to green. But what I like to do is I just say, okay, well, I'm going to take a couple of these, and I'm going to rip them in half, and we're going to just keep shimming this up until we get the result we want. So you take the magnet again. Oh, look, oh, we're still green. You got to make sure it's centered. That's important. It's kind of got to have to eyeball it to get it right. But we're green now, which is good. So now, once you have that thickness, what you do is you just take your standard caliper here, dial indicator, zero it, and get a quick measurement. So about 50 thousandths, which is, I believe, what's documented in the user manual. So 50 thousandths gets us just right. Now, you can go a little thicker. Let's see what happens if we go a little thicker. Are we still green? Because you don't want to be right on the hairy edge. You want to be right in the sweet spot in the middle. So this is much better, because it seems like no matter where I am in terms of eccentricity, that I still get a good green indicator. So I would probably use this thickness. Let's see what this is. And this thickness is about 60 thousandths, so it's about 10 thousandths thicker than the last shim we did. So this is a quick way to just figure out what the air gap is, and you can fold this into your CAD. And if you know it needs to be 60 thou, then you just make sure that it's 60 thou when you make the part and when you design it. Okay, that's going to be all, and thank you very much for watching.